Hi, today I'm going to talk about if material mole parameters should be unique. So here's the story, right? You have some experimental data, you go ahead, you start M calibration, and you calibrate the material mole to the data that you have. So you get some material parameters. Then you realize you didn't wear your lucky socks. You have to go home, you repeat the calibration, and you realize then that you got a different set of material parameters. Is this something you should be worried about? So if you repeat the calibration, should you get the same material parameters? And is it really a problem if the calibration, if you do it many times, gives you different results in terms of the parameters? I'm going to show you by example that this is something that actually is not that important. So here's a window M calibration. I have a virtual load case here. I basically take my virtual specimen, I'm pulling it out to 50% strain in some time. And I've set up a material model that I'm going to demonstrate here. So this is a PolyUMod TMV model. It's a viscoplastic material model that you can organize the way you like. So in this case, I have two networks, and both of them are Yeoh hyperelastic networks. So two Yeoh hyperelastic networks in parallel. And here are the default parameters. And if I run it once, I get some stress strain prediction that looks like this with this set of parameters. But here's the trick now. I'm going to go ahead, I'm going to lock this screen here, this prediction. I'm going to call it prediction 1. And I'm going to change these parameters to be something else. Instead of 0.5 and 1.5, I'm going to make it 1 and 1. And I'm going to run it one more time. And if you look carefully, the prediction is exactly the same. That is, I get exactly the same stress strain prediction with two different set of parameters. So what I've showed here is that it really doesn't matter what the parameters are. You can get, in fact, the same prediction exactly for two different material model sets. And this is just a made-up example with two Yeoh hyperelastic networks. But if you use a more realistic and more complicated material model, there are many cases where the parameters interact with each other in sort of difficult ways to see sometimes. So I wouldn't say that you should try to get unique parameters. And if you repeat this calibration multiple times, you will be in trouble. So to summarize, the calibrated material model parameters don't really need to be unique. You don't need to worry about it if you have good experimental data and if the material model accurately represents the material data that you have. Under those circumstances, don't worry about it if the material parameters are not the same if you repeat the calibration. If you have any questions on this, you can ask them below.